Hi, I'm Mike Thompson. I love science, you guys know that. And I spend a lot of time watching Discovery Plus. And I hear the astrophysicists say things like, there are more stars in the known universe than there are grains of sand on a beach, let alone the entire world. And it kind of makes me wonder, have these guys ever actually been to a beach? There's an awful lot of sand. And this particular sand here is the finest I've ever seen. So I'm going to collect a little bit, I'm going to do a little experiment, and get a ballpark figure for just how many grains of sand are on a beach, and let alone the entire world, and see if these astrophysicists actually know what they're talking about. Well, I'm back at the lab, and I've got the equipment I need, I'm pretty sure, to count some sand. What I'm trying to find out, of course, is the volumetric density, so to speak, is how many grains of sand are in, this much space. So that if I look at a map and say, okay, this beach is a mile long, it's a few hundred feet wide and figure it's several feet deep, how many grains of sand are in that amount of space? I don't care about the actual density of the sand, the weight, per volume. So what I've got here are the things that I think I need to figure this out. Oh, I'm missing my water. Be right back. Okay, so I'm back with my water. What I've got here is a little cylinder. He recently got his diploma, and he's going to help us figure out the size of grains of sand. So here's my test plan. This is a 10 milliliter or 10 cubic centimeter graduated cylinder. I'm going to put water in it up to 5. Then I'm going to count particles of sand as I put them in. As this thing, the water level increases up to 10, I'll simply then divide the number of sand particles that I have, and that'll tell me what the average volume of a grain of sand is then. And of course, we'll have to run this a couple times. Now, the one thing I really don't want to do is count above 1,000, maybe 2,000 tops. So I'm kind of just see how this goes on the first attempt. So I'm going to fill the water up to 5, and then just start counting sand and watch the water level rise and keep track of how many grains of sand are in it as I pass each cubic centimeter. So here we go. That's to the top of the meniscus. I need one more little teeny tiny drop. Boom. 5. Here we go. 1. 2. Nope. Oh, this is going to be bad. 2. 3. 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100. That little bit is 100 grains of sand. This tiny little pile right in here has 500 grains of sand. I didn't make a dent in my sand pile, let alone the bottle. And I put 1,000 grains of sand in this graduated cylinder. They've all gone to the bottom now. And basically, the meniscus has moved its own width, which on this scale here is 0.2 milliliters, or 0.2 cubic centimeters, for 1,000 grains of sand. My goodness. So, it would take 5 times that many to move this 1 cubic centimeter. That's 5,000 grains of sand per cubic centimeter. That's a lot. So let's do some quick ballpark math here and see that's a lot of sand. 16.387. We're going to use all the decimal places because we're dealing with very large numbers. So, this at 16.3871 milliliters per cubic inch is 81,935 we can round. We can round up 1. Is 141,585,408 grains per cubic foot. Okay, but we don't buy sand, we don't build in sand by the cubic foot. We typically do it by the yard. And there's 27 feet in a yard. So we take that times 27. Oh boy, here we go. E9. 3.8 billion. We can go ahead and do the commas. 822, comma 806, comma 000 grains per cubic yard. Okay, and we'll stop at cubic yards because, I mean, well, the whole 9 yards would be that times 9 if you're going to get one concrete truck full of sand off the beach. A cubic yard of beach sand, which is really not a lot. It is slightly less than a cubic meter, of course, for those of you in metric, but 3.8 billion grains of sand. Now, the astrophysicists are saying things like, we're dealing with hundreds of billions of stars. Well, 1 cubic yard of sand is already at 3.8 billion. It doesn't take a lot more to get you into the hundreds of billions. And there are miles and miles of beaches in the world. Let's look at a beach and see, let's pull some dimensions off a beach. How about that? And Alex and I, anytime we go to a beach, we dig holes down to the water line. And it typically is about, yay high, because I go back about so far. And so let's figure the beach is at least 6 feet deep, or 2 yards deep, okay? And let's go pull some numbers and see what we can come up with. Okay, this particular sand sample came from right about here. And so if we use Google Earth here, we can look at the scale and see that if we just pick this part of the beach, we can see that it's got these dimensions. It's 232 feet here, it's 285 feet long, and we've got 148 feet up here. This is a trapezoid, so you average the 2 bases times the height, and this comes out to be 57,000 square feet. Well, that's a nice round number, cool. For you metric people, it's 5,295 square meters. Now, let's just assume it's a 1 yard deep, 3 feet, or about a meter deep. That's 66,333 cubic yards of sand. There's a lot here. Well, you can see there's an awful lot of sand. The calculation from just that one beach shows that there are trillions of grains of sand just in that one little spot of that one little beach. There's an awful lot more spots, and there's an awful lot more beaches out there. So I think when the astrophysicists on TV are making the comparison between the number of stars out there and the number of grains of sand on a beach or on the earth, they are absolutely dead wrong. There's an awful lot of sand out there. In fact, you can see here, if we take the whole 9 yards for a cement mixer to hold the large estimate of 400 billion stars in the Milky Way galaxy, you can fit that many grains of sand in only 12 cement mixers. So there's an awful lot of sand out there. And I think this very quick little experiment shows that. Now, of course, the size of sand can vary a lot. My count could be off by as much as 50%. The grains of sand could be 3-4 times larger. Some of them could be a lot smaller, to the point where they're basically on the atomic scale. But even if all those factors are in play, the vast number of grains of sand that we're talking with here still far outnumber the number of stars that are in any one galaxy and possibly even the known universe. So, hopefully, this fun little exercise in math maybe taught you a thing or two, but at the very least, I hope those astrophysicists on TV start acknowledging just how much sand is really out there on a beach. Go ahead and subscribe if you haven't already. I'm Mike Thompson, and thanks for watching. I really appreciate it.